You hear them all the time, right? Doorbells, school bells. But have you ever actually stopped to think about what's going on inside? That simple ringing sound is powered by some seriously clever science. And today, we're going to pull back the curtain and see exactly how it all works. So, yeah, think about it. When you press a doorbell, it doesn't just go ding one time. It keeps on ringing for as long as you hold that button down. How does it do that? Well, it's not magic. It's a brilliant little piece of physics, and that's exactly what we're going to break down in this explainer. Okay, so to understand the bell's clever trick, we first need to meet the cast of characters, so to speak. Let's take a look at the anatomy of a bell and see all the simple parts that work together to make that sound happen. Now, this might look like a lot of pieces at first, but trust me, they all have a very specific and important job. You've got the gong, which makes the noise, the hammer that strikes it, this moving iron strip called the armature, and the absolute star of the show, the electromagnet. Then we have a spring, a contact screw, and of course, the switch that you press. Let's zoom in on each one. First up, the electromagnet. Now, this is not your average fridge magnet. It's basically a coil of wire wrapped around a piece of iron. And here's the crucial part. It only acts like a magnet when electricity is flowing through that wire. The second you turn the power off, its magnetic power just vanishes. This on and off ability, well, that's the secret sauce to the whole thing. Next, we've got the parts that do all the moving, the armature and the hammer. The armature is just a small strip of iron that's designed to move back and forth, and attached right to it is the hammer. So when our electromagnet switches on, it literally yanks the armature towards it, and the hammer just comes along for the ride. And what does that hammer hit? The gong, of course. You can pretty much think of the gong like a metal bowl from your kitchen. You know, if you were to tap that bowl with a spoon, it'd make that clangy noise, right? That is exactly what the gong does here. It vibrates like crazy to create that classic bell sound. And finally, we have the reset crew, the spring and the contact screw. The spring's only job is to pull the armature and hammer right back to where they started. And the contact screw, well, it's a tiny but absolutely vital part. It's the exact spot the armature needs to touch to complete the electrical circuit and kick this whole process off. So, we've met all the parts. But now we really need to focus on that electromagnet because its ability to switch on and off isn't just a neat feature, it's the bell's secret superpower. And here's why that superpower is so critical. If you used a regular permanent magnet, one that's always on, it would pull the hammer to strike the gong just once. And then that's it, it would get stuck there. The absolute magic of the electromagnet is that it can let go, which allows the hammer to reset and strike again and again and again. Which brings us to the main event. We know all the players, and we know the electromagnet is the key. So how do all these parts work together to create that continuous, non-stop ringing sound?
It all comes down to a really cool process called the make and break cycle. It's this beautifully simple, self-interrupting loop that turns electricity into sound. So let's put all the pieces into motion and see how it works.
You can actually break the whole thing down into 4 really simple steps. First, the circuit is made. Second, the hammer strikes. Third, the circuit is broken. And fourth, the hammer resets. This little loop just repeats over and over at super high speed. Let's walk through it. Okay, step 1, you press the button. This closes the gap, completes the circuit, and boom, electricity starts flowing into the electromagnet. Instantly, it springs to life, creating a magnetic field that pulls that iron armature right towards it. So as the armature gets pulled towards the magnet, the hammer that's attached to it swings forward too. And what's sitting right in its path? The gong. The hammer smacks into it, and we get our first ding. We've just converted electrical energy into sound. But honestly, the cleverest part is coming up next. Now check this out, because this is the genius part. The exact same movement that made the hammer strike the gong also pulls the armature away from that little contact screw. And now there's a tiny gap. That gap breaks the circuit. The flow of electricity is cut off, and in that instant, the electromagnet completely loses its magnetic power. It just switches off. So with the magnet off, there's nothing holding the armature anymore. That spring immediately does its job and pulls it right back to where it started, where it touches the contact screw again. And guess what? The circuit is complete, and the whole cycle starts all over again. This happens so fast, many times a second, that we don't hear a bunch of separate dings. We just hear one continuous ring.
Now, this make and break mechanism is so clever and so reliable that its use goes way, way beyond just doorbells. Let's take a look at where else this simple bit of tech shows up in our everyday lives.
I mean, the same basic idea is what powers old school bells, fire alarms, and even those loud warning bells you hear at railroad crossings. Electric buzzers, which are pretty much just bells without the gong, use the exact same mechanism. It's just a fantastic piece of engineering design that really stands the test of time. All right, we have covered a lot of ground, so let's just boil it all down to the absolute essentials. Here is the science behind that electric bell in 5 key takeaways. Okay, number 1, an electric current creates a magnetic field. Simple. Number 2, electromagnets can be switched on and off, which is absolutely crucial. 3, the bell uses its own movement to cleverly make and break the circuit over and over. 4, this whole cycle is just a beautiful example of energy conversion, from electrical to mechanical motion to sound. And finally, number 5, the super fast repetition of this cycle is what turns a single ding into a continuous ring. You know, the doorbell isn't just a simple noisemaker. It's a perfect, everyday application of one of the fundamental principles of physics, electromagnetism. It takes this huge scientific idea and puts it to work in such a simple, elegant, and useful way. So I'll leave you with this question. Now that you've seen the awesome science hiding inside a simple electric bell, what other devices in your home or at school do you think might be powered by an equally clever idea? The science is all around us, often in the places we least expect it.